Now in section 6, we're going to take a look at some of those special products that we had in an earlier lesson. The perfect square trinomial, the difference of squares, more factoring by grouping, and then solving equations. So you might recall that we had something like this. We said x plus 4, the quantity squared. Well, we'd square the first term, and that would give you a perfect square. Multiply these two together, and then double it. That would give you 8x. Then we'd square the last term, and that would give you 16. Now, the first term is a perfect square. The last term in standard form is a perfect square. The middle sign is whatever the sign is there. And this is a perfect square trinomial. Now, if we took half, well, not half, if we took the square root of 16, because we squared the 4, which give us 4, and then doubled it, we'd get the 8. So this is the pattern we're looking for here. All they want to know is, are these perfect square trinomials? Because if they are, then they would factor nicely. So, is this a perfect square? Yes. Is this a perfect square? Yes. The middle sign is positive. That's okay. We take the square root of 9, which is 3, double it, you get 6. So this is a perfect square trinomial, and we could actually factor it into x plus 3. Now, is this term a perfect square? And the answer is no. So this is not a perfect square trinomial. Now, this one is not in standard form. So if we put it in standard form, we can start to analyze it to see if it is. Let's see if this is a perfect square trinomial. We have to put it in standard form. And this will be a 49 here. So is this a perfect square? Yes. Is this a perfect square? Yes. Now, the middle sign is negative. That's fine. Could be either negative or positive. It's just your end terms have to both be positive. Now, what's the square root of 16? 4. What's the square root of 49? 7. If we go 4 times 7 is 28, and we double 28, we get 56. So yes, this is a perfect square trinomial. And this would factor, once it's in standard form, into 4x minus 7, the quantity squared. So square this, get that. Multiply these two together, double it, you get this. Square the last term, you get that. All right, let's go on. Following our protocol, it's in standard form. So we can go right to this. If we see it's a perfect square trinomial, x there. Now what's half of this term? A negative 6. And that's the factoring of this. And you could use that special technique to check it. Now in this case, this is not in standard form. And this is a perfect square, this is a perfect square. This would be 3 and 5. The square root of these, doubling it gives us 30. So this is going to be a 3z minus 5. And again, you can use that special technique and see if you get that, which you do. Now here, is this in standard form? Yes. Is there something we can factor out of each term? Yes, we can factor actually a 4 out of every term. A 4a, actually. Yes, so now we write it. A squared plus 6ab plus 9b squared. So we get 4a, and the square root of that is a, the plus here, and we're going to get a b there. Half of 6 is 3, the quantity squared, and if we use that special technique, we get that, and if we multiply by 4a, we get this. Okay, let's go on. Well, in letters A through C here, we're asked to determine if these are the difference of perfect squares. And this is not a perfect square, and this is not. So this is no. Now, this is a perfect square, this is a perfect square, and it's the difference. So this is yes. When it is, by the way, it will factor into its conjugates. We'll get back to that in a moment. Now, this one is kind of a little interesting. We could rewrite this in 16 minus 25 x to the 6th. So there's the more typical way of seeing it. And yes, this is the difference of perfect squares. And we could factor that into its conjugates as well. So this would be 2x plus 9, 2x minus 9. These were conjugates. This would be 4 plus 5x to the 3rd, 4 minus 5x to the 3rd. Now, these are all, here we have to do some factoring out, but these are differences of perfect squares. So let's see what you do when you factor those into their conjugates. Here we have to take out a something first. Here, let me study that. Had to think about this one a little bit. So now we can factor them into their conjugates, and let's see what you get. So this would be x plus 8, x minus 8. This would be 6s plus t, 6s minus t. And this would be 2x plus 9, 2x minus 9. These are conjugates. Okay. Now, some of these are challenging. Here we have 4 terms, so we're asked to factor this probably by grouping. So what can we take out of the first 2 terms? X squared, and we get x minus 7. Now here we can take out a negative 9, and we get x minus 7. So there's our common factors, and we'll get then x squared minus 9 in one set of parentheses, and then our other common factors x minus 7. But notice, and this is crucial, here we have the difference of perfect squares. So if you put that in the math lab where it would be correct, you just haven't factored it completely. So we have to factor this into its conjugates. X plus 3, x minus 3, and then x minus 7. Now this one, if we put parentheses here, we see we have a perfect square trinomial, and this becomes a little tricky, a plus 4. So now when we factor this into its conjugates, it will be a plus 4 plus b, a plus 4 minus b. And here this is just putting our parentheses there, and this is going to be x squared minus, again this is a perfect square trinomial. Now I believe when they wrote these out they had reversed the signs. This should have been a negative, this should have been a positive, and then when that's factored it becomes this, and then when we do it we get x squared, or the factors x minus, in parentheses, y minus 5. Guess we can use a bracket there, and then bracket x squared plus, and then in parentheses, y minus 5, and there's no squared there. There we go. Okay, now we clear inner parentheses and we get x minus y plus 5, and then we get x plus y minus 5, and that's what they show below. So in order for that to be true, these signs would have to be reversed there. So every once in a while you do find an error. Alright, let's go on. Now for this one you're asked to find the zeros, and again we have to put that in some sort of organized way. So x to the third plus 5x squared minus x minus 5. So we can factor out of this x to the second, and we get x plus 5. And one of the techniques we had earlier, in order to get an x plus 5 out of these two terms, we have to factor out a negative 1. So this then becomes x squared minus 1, and then x plus 5, and that all equals 0. But again, this is the difference of perfect squares, so we factor it into its conjugates. Equal them each to 0, and we'll take a little shortcut here now, because we can say here x is a negative 1, here x is a positive 1, and here x is a negative 5. Again, if they gave you these as the answers, and they wanted what that original equation was like, you'd have to retrace the steps to get to your function, which is up here. Okay, that'll wrap up this, and good luck.